Hello, welcome to another video on YAGSL's YouTube channel. Hello, welcome to another tutorial on the YGSL tutorials. And today we're going to be showcasing a bit of a different branch of YGSL, in which we're now expanding to yet another mechanical generator. Basically, what this does is allows you to put in your configs, kind of like in YGSL, and it will spit out code which you can use for this mechanism, as well as having a built-in web simulation for you to be able to see your results in real time. You're gonna put here, so there's a bunch of things you have to put in to be able to get the output you want. You can customize your name, what kind of mechanism you have here. You're gonna put in your motor type, whether it's or motor controller type, and then your actual motor, right? So if you're using Neo Vortex, you can use that, or Neo Fit 550. I'm going to use a normal Neo, and then you can put your CAN ID. Although if you're just using the simulator, that's kind of like optional right now because you're only testing with one motor or two motors. Your gear ratio, and yeah, so that's for that. For gear ratio, I'm going to put in, let's put, actually, you know what? I'll just keep it at 15 because I don't really have the robots CAD, and so I'm kind of just showing you what the capabilities of this can do. Here, you have your controller configurations. This includes PID as well as your feed forward, right? So feed forward, you can basically, these are starting values that um, you can use, which is starts at 0. If you're putting in your values and you're realizing it's not working or it's not lifting its load based from the sim, you can try using recalc, right? You press here, opens up recalc, and you can basically put in the same parameters and also get some feed forward values automatically based on that. Of course, you can also get these from SysID later on. This is just, a template for you to use, which you should be modifying uh, throughout the season. Telemetry, you can just keep it as default. I don't really see much use and everything else, but yeah. And then here you have your parameters. This is probably the second important thing to fill out is what your elevator specs are, because what if you wanted to go up 2 meters and your elevator was, instead of 5 kilograms, it was 50 pounds, right? Your jump radius as well, this is going to be your like sprockets and stuff. My team found that to be somewhere around 1.07. It was, yeah, it was 0.7 inches, which we converted to meters, and it's around that from the top of my head. And now we get our simulation, right? So if you want to test, say, if one motor can lift 50 pounds, we'll go run this. And notice how it is not reaching its position. This could either be two things. It's not strong enough, or the PID is a bit off, which we can see that by trying to change PID to maybe 2, seeing if the position's there. So yeah, position's there. This is basically saying that, yeah, so you can see that when I increase P, it simulates that experience as if you were having a real robot. And so you can tune this before you even have a robot built, which is pretty cool, right? And so how can I use this to test if my mechanism is strong enough to lift a certain load? Let's do some changes, right? Let's say my gear ratio, instead of 15, it was actually 3. I feel like that's a small number. I'm just a programmer, but I've been told that 3 is a small number. So let's run that. Oh, look at that. So you see here, now I'm lifting, I'm changing my position, and it's the elevator, it's not moving. Why? Because the load is not strong enough, right? So maybe I couldn't possibly change my gear ratio for some reason, and so I've decided I want a second motor, right? Maybe a second motor would fix my problems. And let's see. And look at that, it did, right? So I would say what I had before with the gear ratio of 15 was a lot more stable than this, but maybe that's because my PID is a bit off. Which of course I can change here. Maybe this should be at 3 instead. So let's reset that. And it's very responsive. You can also go to velocity controls and you know run a velocity test. So this would be like your max speed, which is you can change here actually. Um, let's do that too because I feel slow. Um, yeah, no. So maybe my gear ratio of 3 is not the fastest either, right? I want an elevator to be a bit faster than that. So let's change two motors that have the gear ratio of 15, right? Someone tell me in the comments if these are insane numbers or not. Ooh, that's fun. Well, we can get something from these results. Um, let's go to position. Run. Okay, so looks like it is doing fine. I don't know why it's doing that before. But yeah, so looks like that works surprisingly well. And yeah, that's how you can use YAM to test out your mechanisms before, or your mechanism specs before you even built. Recommended to collab with the programmers, to collab with some like CAD people to figure out these steps before you even start building the robot and just start wasting weeks of your time, right? You can even do the same for arms. Remember, for arms and elevator or pivots, the kg is not used, right? And so if you're using recalc to get the specs and you got a kg value, what you can do is put that in the ks value. Let's see what else. Yeah, so that's the arm, and then here's the pivot. Um, and yeah, that is basically a basic overview of YAMG. Trying to keep this video quick, so hope you're having a nice day and enjoy.